We are taking a look at notebook page 241 and techniques to determine the volume of a sample. So the volume of our samples is the amount of space occupied by all the particles making up the substance. Our main piece of equipment as shown in this picture, okay, is a graduated cylinder. And you'll see me throughout the school year in our notes just abbreviate graduated cylinder as GC. So we have our scaling, and if you've ever noticed, the surface of the liquid is never truly a flat line across. There's a depression there, and so it's kind of like a smiley face. This, what I'm doing is exaggerated. And so when we go to measure the volume in a graduated cylinder, we make our reading at the bottom most point of that depression. So this is where we make our measurement. So measure here. That lowest point in the depression, okay, is referred to as the meniscus. Now, to really make the best possible measurements is that you need to be eye level with the meniscus, that lowest depression. So this eye here, this is you. So the graduated cylinder should be sitting on the surface of the lab bench, and you may need to squat to get there to be eye level. So some different ways that we can come up with the mass of a sample. So the first technique is the simplest technique, is measure the volume directly. And in this, you simply um, add your sample to the GC, to the graduated cylinder, and then get yourself eye level and measure at the meniscus. So get yourself really level. As like when we talked about mass, every time we follow a procedure in the lab, we have to think about what needs to be recorded in our data table. So the data table, the descriptors that are words should reflect back to our procedures. And so simply, what are we going to measure? We are going to measure the volume. So I'm going to have the word volume, and then that volume is going to belong to the sample. Data table, I don't have to have complete sentences, but a few words to put whatever information we record into context with the procedures. So I read the meniscus and it's 12.1 milliliters. So you got to have a number plus a unit. Now, another technique that we will have to implement throughout the school year is volume by difference. The name is very similar to the one on page 240 dealing with mass, mass by difference. So these are methods to come up with a quantity indirectly. So volume by difference. So this is a sample that we just can't easily pour into the graduated cylinder and measure its meniscus. So here we go. So what we do in this is step one, we need to add water to the graduated cylinder. And as a general rule of thumb, I always say, fill the graduated cylinder about halfway. Does that mean that it needs to be exactly 50 milliliters? No, but somewhere in the middle section of the graduated cylinder. So once when you have placed water, halfway up the cylinder, step two, you need to measure the volume of the water. And of course, record it. Once when you've completed that step, Step 3 is now you need to add your sample to the graduated cylinder that already has the water in it. Technique here is important. You just can't grab your sample and then just drop it into the graduated cylinder. Two reasons. Number one, you could drop it with enough force that the water that you've measured the volume of comes splashing out. So now you no longer know the true volume of the water. Or the object could be, you know, dropped with enough force, and if you have a glass graduated cylinder, it could actually crack or break the graduated cylinder. So hold your cylinder at a slight angle and slide the sample into the water. And once when you've placed the sample into the water, now you have a new and different volume. So now you need to measure the combined volume. So once again, we're using that term combined because what is in the graduated cylinder? The original water plus the sample. So the combined, this is the volume of the water and sample. So make sure you understand what is referred to as the combined volume. And then lastly, once when you have all your data, now you can simply calculate the volume of your sample. So reasonable, simplified procedures to get you thinking through the process. When it comes time to do it in the lab, you got to think about the data table and what you're going to record. So the first thing that is recorded or that you have to measure is the volume of the water. And maybe we start off at 25.0 milliliters. The next thing that is measured is the combined volume. So I might simply just put combined volume. And so maybe this is 28.0 milliliters. And then lastly, when I no longer am using the graduated cylinder by making a calculation, when I make this calculation, the final answer represents the volume of the sample. And so 28.0 minus 25.0, my sample's volume is 3.0 milliliters. Now, once in a while, we will determine the volume of a sample by dimensions. And notice our unit has centimeters. So these are using a ruler. Make sure has metric scaling on there. So what we measure and how we calculate the volume will depend upon the overall shape. And so in chemistry, we stick to two basic shapes. So one shape is something that's cubical. Best I can draw it. And once when you see this cubical shape, you probably already know what you need to actually measure in the lab with a ruler. So number one, measure the length in centimeters. Step 2, now measure the next dimension. So measure the width, also in centimeters. And then measure your third dimension that we refer to as height. So measure the height in centimeters. Once when you have those dimensions, now you're actually able to calculate the volume. So this is a mathematical equation you learned probably a long time ago, but let's write it down here. So the calculation of the volume means the volume equals the length times the width times the height. Now you need a data table that is going to reflect the measurements and data you collected. So one of the lines needs to be length, and then width and height. Each of these are measured as a single dimension in centimeters. And so here's the thing, when you're looking at your object, I like to place it in front of myself, and I will do one direction, right, as the length, another direction as the width, and then I need my third dimension for my height. And I don't care which dimension you refer to as length, width, and height, as long as you get all three. And so then, once you have those, then you have your volume. So take a look. You are multiplying the length times the width times the height. It's centimeters times centimeters times centimeters. So the volume's unit is centimeters cubed. Now, the other shape that we tend to work with is a cylinder. So here we have is a cylinder. And once when you see my awful drawing of a cylinder, you probably have an idea of what you need to measure. So step one, you need to measure the height. And of course, in science class, we work metric, so we're going to measure it in centimeters. So that's the height or the length of the column, part of the cylinder. Step two, the other dimension that you are able to measure with a ruler is you measure the diameter, also in centimeters. And so the diameter is the longest chord face across the face of a circle. So what I instruct kids to do in the lab is to place their ruler on the face of the circle and then move it from top to bottom and then see where you get the longest face chord. And where you get the longest chord, okay, that is the diameter. However, so now you have your data, right? And so now you can calculate the volume. The calculation, to calculate the volume, the equation is a little bit different compared to a cube. A cube, it's easy. It's length times width times height. But in a cylinder, you have the length of the cylinder, we tend to call the height, but then we have the face of the circle. So you first need to do some math for that circle. You have to calculate the area of the circle part of it, which is pi r squared. And once when you know the area of that circle, that's two dimensions, then you multiply it by the third dimension of height, right? But we measured height and diameter, but the equation has r in it for radius. So you will have to calculate radius. So you can't measure the radius, but you can calculate it from the diameter. And in case you don't remember, radius is simply 1/2 your diameter. So if you measure the diameter, then you do know your radius and you can calculate the volume. And once again, when you are recording your data, you will have your height, which is in centimeters. You will have your diameter, which is in centimeters. You'll have your radius, which is also in centimeters because this is 1/2 the diameter, right? 1/2 the diameter. And then when you calculate the volume, radius is squared. So whatever this value is you use it twice and then times the height. So you end up with a centimeters cubed.